examples, write in the form a to the power of k, where a is a prime number and k is a rational number. So part A, the fourth root of 125. So to approach this particular question, first thing we're going to do is we first want to get rid of this nth root. And the way in which we can do that is simply write it as an index law. So we'll use our parentheses and go 125. And because it's an nth root or fourth root, we can rewrite it as the power of a quarter. Now the next step is, how can we rewrite 125 as a base to a power? And we can think back and think about, well, what can we divide 125 by? And we instantly see if we divide it by 2, then we're not going to get an integer number. If we divide it by 3, again, we're not really going to get the answer we're looking for. If we divide it by 4, again, that's not going to work. But if we divide it by 5, then we're going to get 5 times 25. And we know that the square root of 5 is going to be 5. So we can break this down into 5 to the power of 3, or to the power of a quarter. Then breaking this down or simplifying it even further, we can get 5 to the power of 3 times a quarter. And that will simplify down to 5 to the power of 3 quarters. So that would be a solution to question or example 1a. Moving on to 1b, we've got something a little bit more difficult. We've got 2 over the fifth root of 64. So we're going to use the same approach, and then we have to go back and deal with this 2 over. So first thing we'll do is we'll go 2 over, and we don't want to have to deal with this fifth root. So we can simply rewrite it as 64 to the power of 1 over 5, like so. And then we're going to take the same route that we did with 125, and we want to rewrite this 64 as a base to a power. So we'll go think about what can we simplify 64 down into, and think about if we divide it by 2, we'll get 32, and once more we'll get 16, 8, 4, and then finally 2. So using that logic, we can break everything down. So 64 can be broken down into 2 to the power of 6. And then that's all to the power of 1/5. And going one step further, we can go 2 over 2 to the power of 6 times 1/5. And that will be simplified to 2 to the power of 6/5, or to the power of 2. Now, here's where we have to take a slight deviation from the previous step. So notice it's 2 over 2 to the power of 6/5. So we don't want to do this denominator. We simply want to have everything expressed in the numerator. So we'll use the rule of negative indices. So this one here, so n to the power of -1 is the same as writing 1 over n, and we'll go in reverse. So what we're going to get is, we'll go 2 times 2 to the power of -6 over 5, and remember this 2 over here can be rewritten as simply 1, 2 to the power of 1. And using our index laws, we can go 2, 1 minus 6 to the 5, and that will work out to be 2, 5 over 5 minus 6 over 5. So it will simply work out to be 2 to the power of -1/5. So again, quite a bit going on to get from this step up here down to 2 to the power of negative 1/5. But we made it. Going onwards, in question 2, we have how should this here be read? And this number over here, it can be read as the cube root of 27 raised to the power of 4. Going down to question 3, evaluate each of the following without using the calculator. So in question A, we've got the square root of 81. So we'll go the square root of 81. We can rewrite that as 81 with the square root, or just the simple radical symbol. Now ask yourself your times tables, and more specifically your square times tables. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 7 times 7 is 49, 8 times 8 is 64, and 9 times 9 is 81. So we know the answer to the square root of 81 is simply 9. Now going across to B, we're challenged with something that is less trivial. We've got the cube root of 27 all raised to the power of 4. So the way in which we're going to tackle this vexing question here is we'll simply go the cube root of 27 raised to the power of 4. How do we deal with this? Well, think about, do we know the cube root of 27? And for most of us, it's not apparent. But think about, what are the factors? What are the factors of 27? And if we drew like a factor tree, we go 27, what can we divide that by? Can it be 2? And the answer is no. Can we divide it by 3? And the answer is yes. So we're going to get 3 times 9. And then doing the same process, 9, the factors of that are 3 and 3. So we instantly know that it's 3 times 3 times 3. So the cube root of 27 is simply 3. And then we're left with the power of 4. So what is 3 to the power of 4? And that can be simply be written out as 3 times 3 times 3 times 3. But that's not a very succinct way to do it. So we can go simply 3 times 3 is 9, 3 times 3 times 3 is 27, and 27 times 3 is 81. So the cube root of 27 all raised to the power 4 is simply 81. Now going down to question C, we're again challenged with a rather vexing looking question, and it is the 4th root of 625 all raised to the power of negative 3. So the first thing we want to get rid of is this disgusting looking negative. So we'll go 625, and it will be the 4th root all raised to the power of 3. And remember, it's 1 over because of this negative. Going down, think about, do we know the 4th root to 625? And probably the answer is no, we don't. So let's think about, can we factorize 625? So can we divide it by 2? And the answer is no, we can't. 3? No. 4? No. 5? And yes, we can divide 625 by 5, and the remainder is 125. Going down again, can we divide 125 by what? And the answer is 5 and 25. Going down again, be 5 and 5. So the factors of 625 are going to be 5 times 5 times 5 times 5. So we know that the 4th root of 625 is simply going to be 5. And we're still raising it to the power of 3, and it's still 1 over. Now moving down, we say, well, okay, what's 5 to the power of 3? And we know 5 to the power of 3 is 125. So the answer to C is 1 over 125. So that's how we could challenge, or that's how we could tackle some of these questions involving roots and powers.